Hi, John Valvano here, and in this video I'm just going to go over Fall 2021 Exam 2. Um, Here, since you could look up the electromagnetic spectrum, you should be able to see that this was a radio. Radio waves are in kilohertz, not megahertz. Why would you want to use radio waves other than microwave? Well, this is a false statement. It's lower bandwidth, so this is false. That's not right. The range is longer. This is definitely true. This is the reason one would use radio. It's very long because of that inverse relationship between carrier frequency and distance. This is also true. This is a very good a reason to use radio waves because they go through objects because their wavelength is longer, and because the wavelength is longer, that makes this false. Obviously, the antenna for radio waves is literally 1,000 times bigger than microwave. All right, that's that one. Okay. Here, what am I looking for? Understanding the way in which sampling fits together. And if you have a sampling rate of, in this case here, are sampling rate of 10 kilohertz, and you have a buffer size of 200 elements, that will determine the frequency resolution of your measurement. So whatever that is, 50 hertz or whatever that happens to be. Okay, so I'm looking for your basic understanding of this and realizing that in terms of frequency resolution, it doesn't really matter how big the A to D is. That would be voltage resolution. Generally, we would put sampling as a high priority interrupt, but it doesn't affect resolution. Again, because the 12 bits doesn't matter. What matters is the size of the buffer. Again, so this information here and the sampling rate there were the two pieces of information you need to determine the frequency resolution. All right. Oh, here's the fun one. Okay, so this is how I would have done measurements. How I would have done address resolution. And what's the key point here is we don't hard code the address. Okay, cannot be pre-programmed in there. The other notice is only 1 through 9 and not 10,000. We'll use that information. And the other is they all come up, but one will come up first. Okay, one will come up first, and then eventually within a certain amount of time they're all up. Okay, so we will go through a address resolution phase for the first 5 minutes, and then we'll go in a use phase later. Okay, so obviously in this particular case it's data logging, and we will be sending data to down here where it says only one node. After the time, each node will know its position and its temperature, and we're going to record temperature versus location versus time. But only one node stores the data. That defines a star. Okay, and the fact that all modules are in range of each other. Okay, we'll use a mesh when you have a lot of modules that aren't in range of each other. All right, so we're going to use a star. Star for the two reasons. One is one node saves, and we'll use a star because all are in range. Okay. Now, it doesn't really say you had to use the first one to be the master, but that's what I'm going to do. That'll be my strategy here, and that is I'll figure out which is the first one. Okay, and so what I'm going to need is I'm going to need some global variables like its address, That'll be the address. We're going to go through a mode situation. In other words, mode 0 will be initializing, mode 1 will be searching for a master, and mode 2 will be I know my address. Okay. Eventually, we're going to know what time it is, and we're going to need some counters to figure out what's going on. Okay, so initialization. We're going to do here, since you did have access to your lab stuff, you know, I didn't grade this very strong, but, you know, I'm assuming you do have access to your lab code. And so again, mode address equals 0 means no address. Okay. This means no address. Yeah. This means, this will mean startup, which means we don't know anything. Time will be 0. This will let us, since we are going to be measuring time in GPS, we'll need the time. And then if we're going to be the master, okay, if we're going to be the master, then this will be the, if we're the master, this will matter. This will be the next address to assign. Okay. And then we'll do the turn on the clock. Again, I didn't take off for this if you didn't do this part. For reasons that I don't know, I always waste power and run as fast as I can. We are going to have Sysdig. Okay, so this is we're going to need a periodic interrupt to run this in the background. It makes sense to me. And I'm going to run this once a millisecond, I think. And the priority don't matter. Okay. This is, no, that's once 100. That's 10 milliseconds. Okay. Run that at 10 milliseconds. And then I'm going to enable, again, we're building this off of the Lab 1 initialization. So I'm going to set this up at 9600 baud. Okay, this will be my UART1 to the HC12. Okay. Enable interrupts. Again, I'm not, you know, I'm not real. When you write code for me in lab, in exam, I don't really care if it's not perfect. As a matter of fact, I can make this a little bit more perfect. And it is a good design to disable interrupts during initialization. Okay. And now I'm just going to wait for the address to be established. And once the address is established, then I'm going to go and do whatever. Now I'm going to go into regular. This will be my regular operation. Because at that point, the address will have been established. Okay. Let's run my Sysdig handler. Again, we're going to use Sysdig both in the regular mode and the startup mode. And I won't do the regular mode because that's not what was asked for. Again, I don't care what you call it, but it should be, when you write me a handler like this, it's I need to know two things. I need to know what caused the interrupt. In this case, it's Sysdig. And go ahead and leave me a comment that this runs every 10 milliseconds. I don't really care if you get the syntax wrong, but running every 10 milliseconds makes more sense than running every 10 microseconds. Okay. So we're going to see if we have any input from the HC12. Okay. Input. This will be a basic time, and then we're going to use the non-block conversion. Again, if you did lab 1, this is really pretty obvious. So this in will be 0 if no data. And it will be non-zero if there's data in there. Okay, so again, I use a mode variable here to sort of go through the various modes. Okay, so mode equals 0 means this is the first time it started up. This is the first interrupt. The absolute first interrupt. And my presumption is, hey, I'm master. Give it to me. You know, I'm master. Okay, so I'm going to pick a code that's not an address, and I don't care what code you choose. I happen to choose a greater than sign. Okay, and what this means. Okay, and again, whenever you write code for me on exam, tell me what you mean. Don't tell me what it is. What does it mean? Okay, it means, can I be master? Because again, I'm more interested in your brain than your code. Okay, can I be master? And now mode equal 1 will mean I want to be master. I want to be master, but checking others to see. Okay. All right. So, and then that's it. Okay, that's it for first interrupt. Well, it might be the second interrupt. Or third or fourth or fifth. Okay, remember mode equals 1 means again, I just said it, but means I'm hoping to be master. Okay, and remember this guy has got data in it or not. Okay, you see that? This guy's got data in there or not. And so it's possible I'm not the master, in which case somebody has responded back to me saying you're not master. Okay, so if the input is equal to something like, what's it, 2 to 2, greater than 2, sorry. So 1 will be the address 1 will be the master, and 2 through 9 will be the slaves. Okay, so this will be the other the one that is the master is going to respond, no, you're not the master. No, I am not. You are, I am this address. Again, the master is going to specify my address. Okay? And so if that happened, my address is going to be equal to the minus, it was 30, whatever. Converted that to be 30. All right. Now I know my address. My address is resolved, and so I'll go on to mode 2. Okay, I'm going on to mode 2, which is telling me, yep, it's all resolved. Okay, so now the question is, if I am going to be master, how long am I willing to wait? Because if I'm master, I sent out this. If I'm master, I sent this guy out, okay, whatever it was, 10 milliseconds ago. How long are you willing to wait until, yep, I am the master, okay? So that has to do with the fact that up here, you see, I gave it a specification that you may assume no two modules power up within 5 seconds of each other. Okay, so that means if I wait 5 seconds, I send out a, I'm master, can I please be master? And nobody responds in 5 seconds, I'm the master. Okay, that's where I'm going to use that information there. All right, so, okay, shift, space. Okay, all right. So that's what I'm going to say here. How long are you willing to wait? Else if. Again, I'm incrementing time every, right? I'm incrementing time. So if time gets to be greater than, let's see, what's some number, okay? Whether that's 100 or 1,000, I don't care. The point is, after some amount of time, I'm going to declare myself as master. Okay? So nobody, if this time here is how long would you expect the master to actually respond to me? Okay, and so if it's greater than that, then I am the master. Luke, I am your father. Okay, so the address will be 1. Okay, address will be 1. I didn't mean to misspell it up here. Meaning I am master. Okay. All right. And then I'm now master. Okay. And to stop looking for, stop looking for someone else to be master. Okay. So mode equals 2 means I've resolved my address. My address is correct. Okay. And count is going to equal 1. So the next 9, 7, 8 nodes who come online, I'm going to give them an address based on this code. Okay. All right. So now, okay. So we've got the else's going here. Okay. Okay. So if time is greater than 100, and I am. All right. So shift else. One more else. Okay, so none of these cases are true, which means actually what I can do here is probably end this one. Okay. And have a new one. If this is if mode or if address equals 1, I'm the master, and in is equal to quote greater than quote. Okay, so this is some other slave, was going to be a slave, is saying, can I be master? You're going to say, no, you are not master. I am master. So I'm going to do a count plus plus, which means this is going to be 2, 3, 4, 5, 6, 7, 8, or 9. And I'm going to send that address back to you. I'm going to send that out, that address back out to you. And that will specify that address. Okay. Well, I'm done. That's it. All right. That's my thinking of this guy. All right. Again, on an exam, I'm not going to count your semicolons and your parentheses, but I am going to read your comments. So again, this means address resolved. I am not master. Okay. All right, let's go on. Okay, I'm sorry. I typed all this crap in here. Sorry. Should read the directions first. Sorry, should have read it. All right. All right. All right. Question 4. What am I looking for in the early part of this class? We talked about phase encoded, frequency encoded, amplitude encoded, and I gave you this is the classic remote control. It uses infrared light, but it's modulated down to a slower frequency other than infrared frequencies. In other words, this is typically down there in the 20-30 kilohertz. It doesn't really matter what frequency this is, except it is frequency encoding. Okay, so you can see that the 1 is a fast frequency, the zeros are a slow frequency. So this is obviously FSK. The actual remote control's probably on-off key and not frequency, but that's a frequency shift. All right, here we're looking for critical section, and remember the things we need for critical section are 3 things. Okay, we need a shared global, which includes I/O ports. Which includes ports. We need non-atomic access. And we need a write. One of the operations is a write. Okay. Those are necessary conditions. They're not necessarily sufficient, but they're things for us to make sure we think about. So the idea here is SysTick is going to interrupt the main program. So right here, if you think about what happens, the processor has to do a read, modify, write. It will first fetch the address. That part is the boring part, the part that I didn't necessarily expect you to know. The next 2 parts you do need to know. We're going to fetch the contents. We can't read, modify, write with 1 opcode on the Cortex-M, and so therefore this is a non-atomic sequence. Okay, that's the whole point here, is that these read, modify, write occurs in 3 instructions. And so if the interrupt were to occur here or here, if we interrupt here, or if we interrupt there, we're going to get the wrong answer. If both occurs, it should have incremented once and decremented once, right? If both occur. But in this context, the consequence of the increment will be lost, and it will just decrement. So this is a critical section, okay? This is a critical section right there, and the way to solve it is to disable interrupts. I suppose you could have thrown away the ARM and used a sys processor, but it's right, enable. Okay. So it's a critical section because the read, modify, write, and the solution is to disable interrupts here. All right, this is going to be okay. We talked about this in class a lot. As you know, the key idea here is information is passed as energy. In this plot diagram, energy is the distance from 0, right? This is the real imaginary for the symbols. Okay, these little circles are symbols that I'm going to encode, and they have all the same amplitudes, but they have different phases. So this is a phase shift, right? This is a binary phase shift key protocol. Is binary because each of the various modulation techniques have 1 bit per symbol. Okay? And all of them but C, okay, so go through 0. Okay, C does not pass through 0, which means that as it goes from one to the other, you don't have 0 energy. Okay, the discontinuities you're going to get on A, B, and D are going to be very large, and it will indeed spread the frequencies all over the place. Okay, so if we want to have a tighter spectrum as we go from 0 to 1 to 1 to 0, 1 to 1, 0 to 0, C will give us the best. Now, the only downside, if you want a downside, is the actual difference in phase is less, right? All the other ones basically have a 180-degree phase shift, whereas C only has it only has a 90-degree phase shift. But that's the disadvantage of C. But the advantage of not going through 0 largely outweighs it. Okay. Okay, thread safe. This is not thread safe. We just did that in the other example. This is false. Because this is a read, modify, write to a potential shared global, which is port 3. This is not thread safe. Okay, choose the best answer. Ooh, okay, this is toggle. No, this is not toggling. This is clearing. This clears the bit. So this is false. This is not intrusive. Okay, so as a debugging instrument, you go back up here and look at this code. You will see that it takes essentially 4 instructions to do this kind of operation. And so, 4 instructions. And at 48 megahertz, that's about what is that? 48 megahertz is about 25 nanoseconds per cycle. So you have about 50 nanoseconds per instruction. This is going to be 200 nanoseconds. And usually this 200 nanoseconds injected into real-time code has a small but negligible effect. Small but negligible effect on it. So that's minimally intrusive. So that's false. This is friendly. That's the definition of friendly. This is the answer. Yes, true. Friendly means only change the bit that you're trying to without. Okay, what that means is only change the bit of interest, bit or bits of interest, leaving the others alone. This obviously the guy here is you can merge programs together. You can merge software together with one software not affecting the other, leaving the other bits unchanged. We just figured it out. Non-intrusive would mean no effect, but 200 nanoseconds is small but not 0. So it's this is false. All right, this one here. What happens first? Okay. One of the questions I could have asked is what. In fact, you can see the typo here in the exam. I meant to ask what the order of operations were. Okay. For some reason, it got lost in the operation, and they are in this order. Okay. But the microcontroller creates the characteristic. It's in BLE device here. It's the phone, and then the BLE device advertises. Okay, so therefore it's the phone who decides to connect. The phone will connect. And then since we're going to do a notification, now the notification characteristic is created and probably disabled into the microcontroller. And when you want to start streaming, okay, you send an update, send a please activate here. And then once it is activated, the microcontroller streams data. So this is actually the exception to the usual rule in BLE that says data transfers is started by the phone and responded to by the microcontroller. But for a notification, once it's activated, data is then streamed. All right, so that's exam number 2021. Come by office hours if you have any questions.